Welcome back, 11th standard students, to chapter 1 sets. In operation of sets, next we are going to go into intersection of sets. But before going into it, I forgot to give you the Venn diagram for A union B. Okay, we'll see what is A union B Venn diagram, then we'll go into intersection. So, as I said, you are going to have the rectangle part. Okay, then you have got A and B. We take the same example. Here you have got the common elements 6 and 8 in both A and B. So, the circle should intersect each other. Okay, this is going to be A, and the next one, sorry, this is not like a circle. Let me rub it off. I put one more circle. It should be in circle form, then only it will form a circle. Oh, sorry, what is going on? I'm wasting your time, children. One more circle. Okay, this is going to be B, and the rectangle, as I said, is a universal set. Okay, now first how will we fill in the diagram? We always put the intersection first. So this is going to be 6 and 8, and then the remaining elements 2 and 4, and here it is 10 and 12. Okay, now what is A union B? So this is union, isn't it? So I'm going to shade those part. Okay, I'll take the blue color pen. So A union B is going to fully you are going to shade all, because all the elements you are going to write, isn't it? So I am shading it with another color to make it visible for you. So both A and B circle along with the intersection is shaded. This is called as A union B in Venn diagram. Okay, so this is above or below, somewhere you have to write A union B. Okay, whenever you draw the Venn diagram, you have to name the sets U, universal set, set B, and you have to name what does this diagram represent always, whether it is A union B or A intersection B or A dash or whatever it is. Okay, otherwise you will not get the full mark. So this is the Venn diagram for A union B. Now we will go into our intersection part. What is intersection? The intersection of the sets A and B is the set of all elements which are common to both A and B. So as I said, which is common to A and B. You know the wordings and. So for union I said it is or, and for intersection it is and. It should be in A and B. Okay. The symbol inverted U is used to denote the intersection. Intersection of two sets are those elements which belong to both A and B. So we write this in set builder. This is set builder form. X such that X belongs to A and X belongs to B. Okay. Now we will go into our example. I hope you noted this diagram. I will delete the diagram. Okay. You will go into A intersection B. Sorry. Okay. Now again A intersection B, we are going to draw the universal set. Next the circle for A. My God, always I am drawing some polygonal for the circle, isn't it? Okay, this is A, and next is going to be our B. Okay, this is going to be our B. Now as you are going to fill in, as usual, the last time also we took the same example, so I am going to fill the same way. Common elements first, then the remaining elements in both the sets. Now what is A intersection B? What is our definition? We have to write the elements present in both A and B. So that is this intersection part. I will color it with a different color. So this part only is the intersection. Okay, where they are cutting each other. What are the elements in it? It is 6 and 8. So this is going to be our A intersection B. Okay, and so this is the universal set, and this figure denotes our A intersection B. This A and B you can write inside or outside, that doesn't matter. Okay, at times you can also write it outside the circle also, that also is good. If there are more number of elements, you can write it outside. Okay, now as you have seen in union, here also they have given another one problem. See what is the problem. Let A be this much and B this much. Find A intersection B and hence show that A intersection B equal to B. Okay, here also you have got 2 both A and B, 3 both A and B, 5 also in both A and B, and 7 also both A and B. So what do you understand? This B set can be placed inside A, isn't it? So you can say B is the subset of A. Okay. Then automatically A intersection B, I told you for intersection you are going to write the smallest set. Okay, the smallest set. So here when compared with A and B, what is your smallest set? B, because all the elements of B is in A, so you are going to get B. So this is the smallest. Whenever you take intersection, it will be the smallest set. Okay. I hope for this Venn diagram you can draw it yourself. Now how will you draw the diagram? Will you draw A and B intersecting or A within B? How can you draw? Automatically you will draw it as A within B, isn't it? Because all the elements of A are in B. Okay, first we will draw B. Then this is going to be B. Then I am going to draw A. Okay, this is going to be A. So what are the elements in B? 2, 3, 5 and 7. The remaining elements 1, 4, 6, 8 and 9. Okay. 9 and this 9 and 10. Okay. So this is going to be our thing. So from the diagram itself you can see A intersection B. What is A intersection B you are getting? I'll color it for you. Oh God, this is not working. So what color we have to color this B part, isn't it? Because that is contains all the common elements. So the elements should not disappear. So I am coloring and shading, putting the line apart. But when you shade with your pencil lightly. It should be seen that you have shaded that part, isn't it? You cannot use colors there. Use your pencil and scale. It will be clear that you have shaded this. So A intersection B equal to, what are the elements you get? 2, 3, 5 and 7, which is equal to B, the smallest set. So this is another tip for intersection. Okay. Then disjoint sets, as I previously told you, disjoint sets, they are going to be apart from each other. Okay. This is the universal set U. Here also I have forgotten to mention universal set. Now here A. This is going to be A and another set B. This is going to be B. Now for example, let me take like this. A as 2, 4 and 6. B as 1, 3 and 5. Now are there any common elements? No. So I will write it as 2, 4 and 6, and here it will be 1, 3 and 5. So these sets A and B are called as disjoint sets. That means they never join or they never intersect with each other. Okay. Therefore this is disjoint set. Then we will go into property of the operation of intersection. The same, whatever properties you saw for union, the same properties you have seen here, but the symbol is intersection. That's all. Similar distributive law also with intersection. There we saw with union, now here it is with intersection. Okay, so I need not repeat these laws. I hope you will understand it easily. Okay students, I hope this will help you better to understand the operations, union, intersection and what is disjoint sets. Thank you.